guys, today for STEM Club we are doing density jars. You can call them rainbow jars, rainbow density, whatever you want to call them. It's a really cool experiment on learning how to see how viscous your liquid is. There's some that are very light, which are going to be the ones that nothing will hold on top of them, and there's some that are very viscous, which are very thick, and so they will sink. So what we're going to do is we're going to do an experiment using rubbing alcohol, water, Karo syrup, or you can use any kind of light corn syrup. You want the light, not the dark. The light works better. Blue dish soap, or if you have clear dish soap, you'll want to put food coloring in it. And some kind of vegetable oil. You can use olive oil, vegetable oil, whatever you have. To make this a visual, this experiment really pop and make you really you can see the layers, go ahead and put some food coloring in it. What we did is we did red for the alcohol, green for the water, purple for the Karo syrup. We used the blue dish soap and the yellow oil. All of these have different viscosities on their type of liquid they are. So what I want you to do now is pause me, and you and your adult or just yourself come up with a good hypothesis and tell us which one you think is going to be the heaviest and which one's going to be the lightest.
This chart shows the density of common liquids, including the ones in our experiment. Use it to try to figure out the layers in our experiment. See if you're right.
Okay, so what we're going to do is after you get them all mixed, this week we're not really offering you anything. You guys are going to use everything from the home. Most of the stuff you'll probably have at home. If you don't, just ask your adult to grab you whatever you need. So you're going to need a clear jar to put your experiment in. You're going to need the alcohol, the water, the corn syrup, the soap, and the oil. Some kind of food coloring if you want. You don't have to, but a couple of the things are all clear naturally, so you want to put something in it. You're going to need a 1 cup measuring cup because you're going to put a cup of your liquid in here to pour into your cups. I'm so sorry. Hi. And a spoon so you can mix everything up. A metal spoon is really good because you can rinse it really quick between usages and it won't stain with the coloring. All right, so when you guessed on what your viscosity was and how dense your liquids were, I'm assuming you guys came up with the syrup as the thickest because that is a very thick, viscous fluid. If you see, super thick. So we're going to put that in first. Did you notice when mixing the purple with you, when you mixed your red and blue, it was really hard to get it all the way in? Look how thick that is. All right, so what did you think was the next thickest? So we're gonna stack them up on how we think. The next thickest is our dish soap. So then we're gonna pour it nice and smooth. Just try and pour down the side so it goes and separates. Nope, you can see it separating there, can't you? All right, so then our next thickest is our vegetable oil. So again, we're gonna go real slow. Next would be our water, which we don't have a representation of our water, but again, just nice and slow, pour it in. And that means our last item is our rubbing alcohol. It is the lightest and less dense of all of our liquids. So we're just going to pour that on top.
To get a really good separation of colors, we recommend using an eyedropper or a turkey baster to really put the green water and the red rubbing alcohol in very slowly.
And as you can see, the layers are separating. It's just really hard to tell right now because it's all in flux. But you've got your purple, your blue, your green, your yellow, and our red. For some reason our green is all the way down here, which just means that the water is thicker than the vegetable oil. So we were wrong on that, so we want to switch those two around. And then what I would recommend is just let it sit for about an hour so it completely separates and see where you're at. So we're going to come back in about an hour and see where our liquids are. Ready? Okay guys, as you see, our colors have separated, and it's really kind of cool because it's almost even perfectly except for our oil and rubbing alcohol level, because they're about the same density, which is why they're like that. So we've got the purple, which is the corn syrup, the blue, that is the dish soap, the purple, the green. From back here, it's a little hard to tell the difference of colors. The green with the water, the yellow with the oil, and then the red with the rubbing alcohol. So it's kind of cool, so you can see the different levels and where it's at. And and it's really cool if you look at how the surfaces are. So if you were to take this and shake it up really good and then set it down, the colors will change, but the densities will not. Anything but the food coloring is a very light and very less dense liquid, so it will actually mix up, but the layers will always go back to the same layers. So that's pretty cool. Just remind you guys, STEM Club is for kindergarten through 5th grade. We do it once a month. Please show us your rainbow jars. I want to see how yours turned out. If you try something different, like maybe using honey or anything around the house like syrup, see what happens. Tell us what your results are in the bottom. Just drop it down below in the comments. We'll miss seeing you. Bye.